Greetings and welcome to PinballHelp. Mike here. Right now I'm working on a Bram Stoker's Dracula, and I've been having a problem with the missed multiball not working. Now, if you're familiar with this game, the missed multiball is one of the coolest features on this machine. It's actually a magnet that drags a pinball machine across the center of the play field to start multiball. It's a really, really cool feature, and I think it's one of the neatest toys in all of pinball. And what it involves is there's a kind of a rail underneath the play field, and this magnet assembly moves back and forth based on a motor and a kind of a drive screw that makes it go back and then forth. So let's take a look at this and let's figure out how to diagnose problems with the missed motor and the magnet assembly. So let's pull the play field up. And this game has got some kind of weird rail situations here on it too. This is a game that's probably been operated in a bunch of different capacities, and I can already see there's been some weird operator related stuff done to it. So here you can see this is the assembly for the missed multiball. This is the rail that the magnet travels on, and over here is a motor, and this is the gearbox, and it goes back and forth. So our issue today is this motor is not driving. So I'm going to show you how you can diagnose this issue. So the motor is driven right here by these two wires, and let's zero in on that so you can get a little bit better look at it. So there are these two wires. This is kind of in the way, but these two wires, so this runs on 20 volts DC. It turns in one direction only. There's a thing here that flips it so it will go back the other way because of the way the gear is done, and it basically just turns on and goes back and forth. So you can measure voltage using these two wires. One of them should always have positive voltage to it, 20 volts. The other one is going to go back through the solenoid driver board, and I believe it's tied to solenoid 28, if I recall correctly. So when the motor is scheduled to turn on, solenoid 28 goes to ground and then completes the circuit. So you should be able to measure 20 volts DC off of one of these leads. Now let's follow this back so we can see if it's an issue with the motor or the connections. So let's go around here to the other side and take a look at where this thing goes after. So after there, it goes to this little coil, this board with the two coils on it. This is our control board for the motor. And you'll see in this case there's two IDC connectors, but there's no wires connected to it. So whoever worked on this game last soldered the wires to the underside of the board. So normally they would be connected to these plugs, and they're not. But you can test for voltage on these pins on either side. It's coming in here and it's leaving there. In this case, they've soldered them to the board, but I can still test. So put a meter to that while the game is on, and we should be able to read 20 volts there. Obviously, this is a less than ideal situation. This doesn't really bother me that much because I guess if you need to replace the board, then you have to desolder them instead of just unplug them. But as long as this is working, and I don't know if it's working just yet, but I can tell, I've already checked that there's no voltage going to that. So we have no voltage going to the motor. So let's investigate further. What's next up the chain? So I'm going to put the play field back down, and we're going to take a look in the back box. All right. So let's go take a look over here and see what we are dealing with. All right. Okay. Let me move our light around to the other side so I'm not casting some big shadow on it. Okay. So this is our power driver board right here. And this is, woo, the stud in my face so I can't hardly see. So let's talk about where the 20 volts comes from. Now, I turned the game on before, and I realized that there is an LED for the 20 volts. It sits in between these two caps here, and it's right there, and it was not lit up. So that was one of my indications that there was an issue. But the proper way to check this is you can run, there's a test point down here that shows the 20 volts right here. You could take the black lead, hook it to a brown grade, test right here, see whether you got 20 volts or not. Now, I'm actually doing this video after I've done the repair. I did a video before it, but the video got glitched, so I had to go back and redo it. So I'm redoing it. So this is the board after I've already repaired it, so I'm basically going over how I discovered there was a problem. So I discovered that the 20 volts was completely out on the board. And then I just backtracked and said, what on this board is in that circuit, and let's get to fixing it. And what I found is it comes in, it goes to this capacitor here and this bridge rectifier BR4. And then it also passes through this big resistor right here. This is R224. When I first looked at this on the board and I put a meter on it, it almost read like it was shorted. It was like such a tiny, like 0.1 ohms. And I thought, what's going on with that? It doesn't make any sense. Then I did a little bit of research and I realized that this is the same circuit that powers the flashers. And the reason for this big resistor here is to put a little bit of resistance on the circuit to help protect the flashers. Apparently when they're cold and you fire them, they draw a lot of current, and that current can cause some RF interference, and it just makes the circuit run a little bit better and more efficiently. So that's what the purpose of this thing is there. It's just to put a little bit of resistance in the circuit. It goes through all of this, and that's it. So I basically, in the next series of videos, you'll see I pull the board out and I get ready to work on it. And there's an interesting little surprise that I encountered when I do that. So this is where I am in this part of trying to figure out why we have no 20 volts. I also realized that that's also the voltage for the flashers. So the flashers were out as well. So this is your same process for diagnosing flashers and sometimes any other toys or motors that might use that 20 volt circuit. So you check that, it's going to be bridge rectifier 4 and this capacitor here, and of course obviously there's some fuses that are in line, you want to check those first. So take a look at the next series and you'll see I pull the board out, I encounter another problem, and we continue from there to get the game working. So for more, visit pinballhelp.com and be sure to subscribe at YouTube/pinballhelp. Thanks for watching.